Okay, so let's proceed to example 4. So, a 101.3 milligram sample of an organic compound containing chlorine is combusted in pure oxygen gas and the volatile gases collected in absorbent traps. So, you are told nga it's an organic compound, diba? So, that means it must contain carbon, hydrogen, and chlorine. Kaya niya naman siya, kini, ang carbon, hydrogen, that's the component of organic compounds, diba? And then chlorine, you are told nga it contains chlorine. So what's happening here is that iyan ang i-combust this compound. So this is the compound containing this one. We just don't know kung pila we don't know yet kung naabay laing elements present. So sa first statement, maura niya itong ma-conclude, maura niya itong ma-deduce, diba? So ang gibuhat is that this sample containing these elements was combusted with oxygen gas and it formed volatile gases. So, upon combustion of organic compounds, you will form carbon dioxide of water. Okay, we know this thing that complete combustion of organic compounds produces carbon dioxide and water. Okay, so what's the setup for this class is that if you have this sample, for example, na mao ni mong reactor, and then gi-introduce ni mo dira ang oxygen na kay inlet dira for the oxygen gas. So once this reaction, the reaction occurs, once mo occur na niyang reaction, then it will produce these volatile gases. So these are in gaseous states. So once mo produce na sila, then ang volatile gases will be absorbed in these absorbent traps. So these absorbent traps should be weighed first kay ma-determine raman nimo ang mass of CO2 o mass of H2O produced by weighing, by subtracting the difference of these absorbent traps, diba? So kini ni absorb ni sa CO2 nya, kini ni absorb sa H2O. So lain-lain ni sila, made of different materials. So this material could absorb H2O and this material could absorb CO2. Okay? So once na kay mass after the reaction, then you can subtract it to the mass of these traps before the reaction. So in here, we are told nga it produced 167.6 milligrams of that, and it's 13.7 milligrams of H2O. Diba? So, initially, we have, in experiment 1, initially, we have 101.3 milligram sample. And then, it produced 167.6 milligram CO2 and 13.7 milligram H2O. So whatever carbon ang whatever amount of carbon ang present sa CO2, all of this comes from the sample. Gikan aning 101.3 milligram of sample, di ba? And whatever H nga gikan sa nga na-produce sa H2O, all of that H comes from the H nga gikan sa still gikan sa 101.3 milligram sample, because we only introduced O2 to the sample, di ba? So this oxygen, ang oxygen ani could most likely it comes from this, and if ang atong sample nag-contain og oxygen, then it could be a mixture, di ba? So what we can get from this, ang ato rang ma-get from these are the percent carbon nga naa sa sample ug ang percent hydrogen nga gikan sa sample. Okay? So for experiment 2, para ma-determine po ang chlorine, they made another experiment. So nigamit sila og 121.8 milligram of sample, and then they treated the sample with concentrated nitric. So ni-produce og chlorine. And then, ang chlorine, ilang gipa-react with silver. As you know, kung i-react nimo ang chlorine with silver, it forms silver chloride. Diba? It could precipitate. So, ang silver chloride nga na-form is 262.7 milligram silver chloride. That means nga whatever chlorine, whatever amount of chlorine is present in this silver chloride, all of that chlorine comes from this sample. So we can also take from here the percent chlorine. Now, nganong percent man jud atong kuhaon? Because ang percent is relative to the amount of sample. So we will not just get the amount of carbon, amount of hydrogen, or amount of chlorine, because dili man nato sila ma-relate if we just use that, because silang tanan gikan og ang chlorine, it comes from 121.8 mg, but ang carbon o ang hydrogen, it comes from 101.3 mg, di ba? So dili nato sila di nato ma-normalize. Okay, so to normalize that, we have to use percent. Kaya ang percent, it's relative to the mass of the sample. Okay? So in ano ni class ba, if I have 100 if this is 50 gram of sample and this is 100 gram of sample, kung same ni sila og identity, okay, if these are the same samples, just different weights, then whatever percent carbon is present here is equal to the percent carbon is present here, or percent hydrogen nga naa dira, it's equal to the percent hydrogen nga naa dira. So that's why we need to get the percent. And an advantage of that class is that if we know the percent of these elements, then if i-total nato nga i-total nato sa percent, if it sums up as 100%, then we will know nga this sample contains just these three elements, diba? And if it's not 100%, then that means there must be some other element or elements present in that sample. Okay, so that's why if you have problems like this, it's safe to use percent, because you don't know if nailaing element present. Okay, so from experiment 1, okay, so let's remove this one. Okay, so from experiment 1, we can get the percent hydrogen. Let's start with carbon. So we have 167.6 milligram CO2 times that's 16 times 2 plus 12, 44 milligrams. This is the molar mass per millimole CO2 times 1 CO2 has 1 carbon, diba? That's 1 CO2 contains 1 carbon, and then for every mole of carbon, you have 12 milligrams. Sorry, 12 millimole, you have 12 milligrams of carbon. So makancel na, and you're left with milligrams carbon. So this is equal to 167.6 times 12 divided by 44. So that's yeah, 45.71. milligram carbon. So that means ang percent carbon is that's equal to 45.71. So let's just, so that means percent carbon nga present sa sample is 45.71 over the mass of sample 101.3 times 100, which is equal to, that's 45.12% carbon. Okay, so let's proceed with hydrogen. So let's start with 13.7 milligram of H2O. So the molar mass of H2O is 18 milligrams per millimole H2O, times for every 1 millimole of H2O you have 2 millimole of H, times for every 1 millimole H you have 1.01 milligram H. So you get 1.01 times 2 times 13.7 divided by 18. So that's 1.537. This is 1.537 milligram H. So percent H will be equal to, so same, 1.537 over 101.3 times 100 is equal to 1.52. So that's 1.52% H. Okay? So from experiment 2, we can get the percent chlorine, di ba? So that's 262.7 milligram AgCl times, okay, so the molar mass of AgCl is 143.32 milligrams per millimole AgCl times, for every 1 millimole AgCl you need you have 1 millimole chlorine, di ba? Times, for every 1 millimole chlorine you have 35.45 milligrams chlorine. So now here you can get the milligrams chlorine. So that's 35.45 times 262.7 divided by 143.32. So it's 64.98. That's 64.978 milligram chlorine. So percent Cl is equal to, that's 64.978 over 121.8. That's the amount of sample divided by 121.8 times 100. So that's 53.35. 53.35% Cl. So if you add this up, plus 1.52 plus 45.12, you actually get 99.99%. So which means that this sample, okay, this sample only contains these three elements. Okay, na total man siya og 99.99%, which is approximately 100, di ba? So that means it only contains these three elements. So if we can just compute for the to know the empirical formula of the compound, so we convert these grams into moles. Okay, so you have okay, let's convert these into moles. Okay, so you have this is 45.12% carbon. So let's use 45.12%. So wait sa class. If we use these amounts, diba, remember nga these are not normalized, kay kini siyang sa chlorine we used 121.8 grams of sample, milligrams of sample. So of course, if we had used the same amount of sample nga 101.3, if we had used that amount of sample, then we can just directly use this, kay pareho ra silang amount of sample. Kay if we used 101.3 for chlorine, if we used 101.3 sample, pag analyze nato sa chlorine, then of course gamay unta ni ang milligram sa chlorine nga makuha nato, diba? Kay gamay ra man ang amount of sample. But since lahi man sila og amount of sample, then we cannot use this. We can only use this if we take the kanang ratio and proportion. So we take the amount of sample that would have been produced had we used 101.3. So we could convert this into So if we were able to produce 64.978 milligram chlorine for every 101.8 milligram sample, then we can use the ratio and proportion wait, my pen's not working. Okay, so we can use the ratio and proportion nga to ask how much chlorine would have been produced if we had used 101.3 milligram of sample. Same sa sample nga gigamit nato to analyze carbon and hydrogen. Diba? So, this case, X would have been, the amount of chlorine would have been 64.978 times 101. Sorry, let's just... That's 54.04. So see, we could have only produced 54.042 milligrams of chlorine if may gamit pa ta og 101.3 milligram sample. Dili 64 atong makuha, di ba? So we can use this amount, and this amount. Kay pareho naman sila og gigikanan. All of them come from 101.3. We can also directly use this to solve for the moles since percent naman sila. So they basically mean na natay 45.12 grams of carbon for every 100 gram sample. Diba? We have 1.52 grams carbon for every 100 grams sample. And this one we have 53.35 grams this is hydrogen and this is chlorine for every 100 grams sample. Diba? Mao na ang pasabot sa percent. So if you notice, kung percent imong gamiton, they're already equalized. So that is why we computed for percent. So let's just use this one, okay? So to compute for the moles of carbon, we have 12 grams per mole. So we just use the molar mass, so that's 1.01 grams per mole, and this one is 35.45 grams per mole. Okay, so this is the mole of each element present in every 100 gram sample set. That's 3.76. This one is 1.52 divided by 1.01. That's 1.505. This one's 53.35 divided by 35.45. So that's 1.505. So now you have the moles of each element, okay, present for every 100 gram sample. So to compute for kung pila iyang empirical formula, di ba, we can't have these things nga kanang we can't have a chemical formula nga raised subscript kay 1/2 or subscript kay 3/2 such as this one. So we need to multiply this into something that would give us a whole number. So first we multiply this by 2 such that everything could give us whole before multiplying that, we have to normalize again. So we have to divide everything with the smallest number of moles. So in this case, ang H ug ang Cl pareho silang 1.505. So we divide everything by 1.505. That's to normalize. Okay, so this will give us 3.75 divided by 1.505. So this gives us 2.49. This will give us 1 and 1. So these ones kini okay sila nga ma-subscript, di ba? Nga 1, ya 1. But we cannot have a subscript that is 2.5, di ba? Dili ta pwede maingon nga C2.5H1Cl1. We cannot do that. So, we have to multiply this to the lowest number possible nga dapat whole number ang ilang makuha. So, let's multiply this by 2 first. So, if we multiply this by 2, that will give us 5, and this will give us 2, and this will give us 2. So, now, they are all whole numbers. So, that means we have 5 moles of carbon, 2 moles of hydrogen, and 2 moles of chlorine. So, that's C5, yeah, H2Cl2. Okay?